Hello, everyone. Today we are back, Algebra 1, Lesson 2.10. Not 2.1, 2.10, because it is for Unit or Module 2, page 10. Okay, so we're going to get started here. And we just went over some linear inequalities. So we're going to actually shift gears a little bit here. We've been doing, this unit mostly has been linear equations, then we transitioned into linear inequalities. So the next step for us today is to talk about algebraic sequences. Okay, algebraic sequences. Now, if you remember, a sequence is something that continues in order, like, and it's a predictive order, like you can tell what's going to come next. For example, when you used to do skip counting or your multiplication tables, 2, 4, 6, 8, 10, you wouldn't say 2, 4, 10, 6, 12, -8. That's not an algebraic sequence because it's out of order, right? You got to have a predictive amount that you can increase or decrease it by. And in order to make it algebraic, you're either adding or subtracting to each term. So here we have an arithmetic sequence is a special type of function because for every input, there's only one output in this type of function, right? It's a series of numbers that increase and decrease by the same value every single time by adding or subtracting only. So 3 to 5, what did we do? We added 2. 5 to 7, we added 2. 7 to 9, we added 2. What's the common difference? It's adding 2, right? Now, each one of these things are called terms. So the first term is 3, the second term is 5, the third term is 7, and the fourth term is 9. Dots mean, these ellipses, means it continues on forever. It's an infinite series. There's no end to it, right? Sometimes these are called elements or members. It's the same thing. Now, in order to see how this can be a function, it's going to help us if we take, well, actually, before we get into the function part, let's look at and determine, are these going to be arithmetic sequences or not? Okay, so we just looked at a sequence and we determined that they were all, the one we just looked at, everything was set at a difference of 2. It was a common difference. So it was the same between every number. So we need to look at these and see if there's a common difference in between each and every one. So 3 to 7, well, 7 minus 3, or you can just count up 3, 4, 5, 6, 7. There's 4 there, right? Okay, let's look at the next one. 7, 8, 9, 10, 11. There's 4 there. You really only need to have 3 to determine if it's going to be a sequence, but we can continue on here and say between 11 and 5, that's obviously 4. So this one is an arithmetic sequence. Between 1 and 4 is 3. But if we added 3 more to 4, 4, 5, 6, that'd only be 7, not 9. So that's a difference of 5. And between 9 and 16 is a difference of 7. So this does not have a common difference. This is a sequence. It's not an arithmetic sequence. We'll get into those later. All right, -8 plus 2. Oh, nope, minus 2 is 10. Minus 2 is 12, and minus 2 is 14. So these are, this right here is an arithmetic sequence. 10 to 7, okay? 10 minus 7, 7, 8, 9, 10. There's a subtract 3 is the difference. 4, 5, 6, 7. Subtract 3 is the difference. But then we're back to 10 again. We added 6. So is this an arithmetic sequence? No. So even though these are closed sequences, if you notice, they don't go on forever and ever. If they go on forever and ever, you know they repeat the same pattern over and over again. But with a closed sequence, you definitely want to check each and every term or element in the set. So we had 2 arithmetic sequences, and this was still a sequence, but not arithmetic. This one is not a sequence at all. Okay, just not. All right, so let's look at a sequence and see what it would look like as a function. Here we've gone ahead and we have the sequence 2, 4, 6, 8, etc. And so as if you're skip counting or your multiplication tables of twos. So we've created a chart here. Now, here we have the 2, the 4, the 6, the 8, and it's going to continue on. And then we're numbered every term. So this is the first term, this is the second term, this is the third term, and this is the fourth term. You can see right here, it's called its position number. Position 1, position 2, position 3, position 4. This is the independent variable. We're going to call it n, okay? So the second term. And then f of n is the dependent term. It depends on what are we looking for? Are we looking for the first term, the fourth term, the seventh term? Depending on which term we're looking for determines what our answer is. So this one is dependent. Now you know that an independent term is always going to be the domain, and a dependent term is always going to be the range. So this is the input, this is the output. And from this table, you know that the fourth term is 8. And another way to write that is f of 4 is 8. Okay, so this is looking at it like a function. We're getting ready to see it like a function. However, when we have functions, we should be able to find a way to write it as an arithmetic sentence, right? We want a math sentence, an equation, as it were, something with an equal sign. So we have a formula that helps us with arithmetic sequence. So a lot of times you'll see it as x of n, or x sub n, excuse me, x sub n is a plus d times n minus 1. Now, this is very helpful, but in our program, we're going to be writing everything as functions. So I prefer that you write in your notes this right here. F of n is f of 1 plus d times n minus 1. And in that case, instead of writing a as the first term, so in this case, a is the first term, right? Well, in this case, f of 1 is the first term, because remember, every time we want to know what something is, we can write it as the name of a function when we have a function. So a is the first term, f of 1 is the first term. That's the only difference besides the, right here, the y value or the answer value, the output value. What that is. Instead of writing x sub n, we wrote f of n. This is more familiar to us, and that's why I want to go with this route. But you might see in some books you read or on the internet, if you're doing some additional research, this formula as well. Both of these are accurate as long as you know what everything is. A, in this case, or f1, is the first term, right? D is going to be the difference, the common difference between the terms, okay? And then N, here we have an N, right? And that means the number of terms or which particular term you're looking for, because you might be looking for the 9th term or the 107th term, okay? Now, when you have this formula filled out for an arithmetic sequence, it has a special name. It's called the explicit rule, okay? And it is based on the first term. So you include right here the first term, F1, right? So this is the explicit rule. So let's put that formula to work for us. We have the formula written up here. If you want to see it the other way, it would be x sub n is a plus d n minus 1. Okay, so let's put that formula to work. What is the explicit rule in its simplified form for the sequence 7, 12, 17, and 22? So we're just going to start plugging stuff in. We're going to leave f of n as the answer equals. Right here, we need to input the first term. The first term in this case is 7 plus, okay? Now we're looking at the D. Well, we actually have not yet determined the D. That's very important to do. It may not even be an arithmetic sequence. In that case, we couldn't write an explicit rule. 7 to 12, 7, 8, 9, 10, 11, 12. There's 5 difference between them. 12, 13, 14, 15, 16, 17. There's 5 difference between them. You could just plug into your calculator or do mentally 12 minus 7 is 5, 17 minus 12 is 5, 22 minus 17 is 5. Okay, so D in this case is 5. All right, so that's what we're on. We're plugging in D right here, 5. Now, since we're writing an explicit rule and we still have N here, then we're going to continue to have N minus 1 right there. N is taking the place of what we would normally see in an algebraic expression of X, okay, or an algebraic equation. So we're going to use N in place of the X here. So now, it did ask us to have it in simplified form. So since we see parentheses in it, we know it's not in its simplified form. So f of n is 7 plus, we're going to go ahead and distribute this out by multiplying 5 times n, which is 5n, and 5 times -1, which is -5. Okay, now we're going to combine like terms. So f of n is 5n, that's my term with the variable. So if I'm going to write it in the proper format, that's going to go first. And then my common terms are going to be my constants, a -5 and a +7. Since they have different signs, I need to find the difference. And that's 2. 7 minus 5 is 2. Now, what's going to go in front of it? Is it going to be a plus or a minus? Well, it's going to take the value of, or it's going to take the sign of the number that we just used, the 2 numbers, whichever value is greater. 7 is a greater value and it was positive. So we're going to have our 2 be positive. So our final answer for the explicit rule is f of n is 5n plus 2 for this arithmetic sequence that we have right here. All right, so let's move on to the next one. It says, what is the 9th term in the sequence 3, 8, and 13? So let's find the difference between these. 8 minus 3 is 5. 13 minus 8 is 5. So our D is going to equal 5. All right, well, this looks like it's going on pretty well. Now, I know how to find the explicit formula here. I'm going to keep my f of n, and I'm going to look for my first term. My first term is 3 plus d, which I know is 5 times n minus 1. Okay, so that's my explicit formula. I'm not going to simplify it because it's not asking me for the formula, so I can actually keep it in this format right here. What it's actually asking me for is the 9th term. This is what's going to go into the n spot. This is basically what we're doing here now is substitution, just like when you were given a problem before in algebra and asked for to evaluate the expression if x were 9. So in this case, instead of x being 9, n is 9. So what we're actually looking for is f of 9. So in this case, we know anytime we see an n in the formula, we're going to input 9. So 3 plus 5 times n minus 1. And that's why I did not need to simplify this, because I can, number one, just plug this into my calculator and get an answer, or it's easy enough for me to do myself. 3 plus 5 times 9 minus 1 is 8. F of 9 is 3 plus 40. So the 9th term of this sequence is 43. All right, So here we have another arithmetic sequence, right? And we're going to look at this chart. This is the chart we had at the beginning where we had 2, 4, 6, 8. We're skip counting by twos or counting our multiplication tables out, right? So I've got some questions for us based on this chart up here. Number one being, what is the explicit rule for this sequence? Okay, well, I wrote the explicit rule up here for us if we want to use it. And remember, you could always write this as x sub n is a plus d n minus 1 if you prefer using x and a. But we're going to stick with the f with it written as a function instead of an not expression, an equation. All right, so what is the explicit rule for this sequence? We're going to start with f of n is f1 right here. That's our first term. Our first term is 2 plus d. What's the difference? Well, we said we were skip counting by twos, so our difference is 2. Between 2 and 4 is 2. Between 4 and 6 is 2. Between 6 and 8 is 2. So our difference, d, is going to equal 2. So put 2 there, and then n minus 1. And anytime in your curriculum you're asked to write an explicit rule, they are going to expect you to simplify it. So let's go ahead and distribute this 2 out to each of these terms. F of n is 2 plus 2 times n is 2n. 2 times negative 1 is negative 2. Let's combine like terms. F of n is 2n. There's no other term that's like that one. Our constants, however, are like a 2 and a negative 2. Well, 2 minus 2 is 0, so they're going to cancel out. So our final equation, the explicit rule, is f of n is 2n. And that's the case anytime you have a multiplication table. If you're counting by threes and you started at 3, it would be f of n equals 3n. F of n equals 5n if you're skip counting by fives. So that's your explicit rule for this sequence. Now, the next question is, what is the fifth term of the sequence? Well, we weren't given the fifth term, so this is actually pretty easy for us because we already know that the fifth term is going to be 10 because we're just smart like that, right? Because if you skip count or count your multiplication tables up to the fifth one, 2, 4, 6, 8, 10, we know it's 10. But we should be plugging it in, right? F of 5 is 2 times 5. 2 times 5 is 10. It checks out. We got it, right? F of 5 is 10. All right, so what term would be described as f of 3? F of 3 is 6. We didn't even need to do anything except look at the chart this time. Okay. Now we've gone over explicit rules. There's also a recursive rule. Now, explicit rules, when we talked about those, they were based on the first term. There's also the recursive rule is based on the previous term and not necessarily the first term. So we have here a recursive term written out for you. And if you remember, we said in our last one, we had f of 1. In this one, we have f of n minus 1. And this means previous term. So if we look at the formulas, here we have the explicit rule and the recursive rule. If you look at the formulas, the n minus 1 is being multiplied by the d in the explicit rule. And you start with the first term. If you look at the recursive rule, the n minus 1 is right next to the f, and there's nothing next to the d. So basically, the recursive rule is just a matter of adding to each term what the common difference is. So if your common difference is 5 and you had a term of 2, your next term is going to be 2 plus that 5 is going to be 7 plus another 5, 7, 8, 9, 10, 11, 12. And you're going to keep going. Okay, so the main difference is the explicit rule is based on the first term. The recursive rule is based on the previous term. Those are the main differences you have to think of. Okay. Now, when you have the recursive rule, you also have to give one of the points. And we'll look at that in just a moment. So here, we're asked to write the first 4 terms of a sequence given that f of 1 is 2. So they gave us one of the terms, f of 1 is 2. I'm going to fill in the chart with the information I have. F of 1 is 2. Okay. My n is 1. My f of 1 is going to be 2. All right. And f of n is 2 times f of n minus 1 minus 1. And it says solve it for n is greater than or equal to 2. All this means is, hey, we already gave you the first term, so you just have to solve for terms 2, 3, and 4. That's all this means. Don't get confused by it. It just says we already gave you one answer, so you don't need to work on that one. Okay? All right, so we're looking for 3 pieces of information here. Well, if this is our formula, all we have to do is plug it in. Well, the thing to remember is that this is our previous term. This meant, remember, previous term. Okay, so if we're looking at an n of 2, then you're going to plug in the previous term, which was 2 here. Okay, so we're going to look for f of 2. F of 2. We're going to plug in 2 times the previous term of 2 minus 1. So f of 2 is 4 minus 1, and f of 2 is 3. So there we have 3, right? All right, so I'm going to show you how that worked out. If you don't remember that this is your previous term, it's okay. You're still going to get it right if you just plug everything in. F of n is 2 times f of, oops, we're not doing f of n. In this case, we're going to be doing f of 3. All right, 2 times f of 3 minus 1 minus 1. So f of 3 is 2 times f of 2 minus 1. Oh, look, it's f of 2. I know what f of 2 is. F of 2 is 3. So I'm going to plug that in. 2 times 3. F of 2, I happen to know, is 3 minus 1. So 2 times 3 is 6. Minus 1 is 5. F of 3 is 5. All right, so let's look at f of 4. F of 4 is 2 times the previous term. The previous term in this case, we're looking for 4. The previous term is 5. 2 times 5 minus 1. Order of operations tells us we're going to do multiplication first. That's 10 minus 1. F of 4 is 9. Okay, so we were asked for the first 4 terms, terms 1, 2, 3, and 4, and we got it done. All right, so here we're asked, we're given a table, and it shows the balance at the end of each month in a bank account. This is a real world example, and this bank account does not earn interest. This is a really real world example. It's hard these days to find a checking account that earns interest. So month and balance here, we have to determine what's our input, what's our output, what's independent and what's dependent. Okay, well, the month can't depend on the balance, so the balance must depend on the month. So the month is going to be the domain, and the balance is going to be the range. So the domain is independent and the range is dependent. That means the month we're going to call n and the balance we'll call f of n. All right, so we're asked to write a recursive and an explicit rule for this sequence described by the table. Well, the first thing I know in both of these equations, which I don't have written down, the first thing I want to do is write them down. F of n, we'll call this one E for explicit and R for recursive. F of n is f of 1 plus d times n minus 1. And the recursive is f of n is f of n minus 1 plus d. Okay, so both of these equations have a d. We need to figure out what the difference is in the range, between the terms. So between 30 and 60, we have a difference of 30. Between 60 and 90, there's a difference of 30, and 90 and 20. They all have a common difference of 30. So our D is going to equal 30. So let's first write an explicit equation. It's going to be f of n is, our first term is 30 plus the difference, 30, times n minus 1. Now we need to simplify. So f of n is 30 plus, let's distribute this, 3 times n is 30n. 3 times negative 1 is negative 30. Now let's combine like terms. We're going to start with 30n right here. We move that to the beginning. And then our common term are the constants, a positive 30 and a negative 30. Well, those are going to cancel out. So our explicit formula is f of n is 30n. All right, now let's look at a recursive formula. F of n is f of n minus 1 plus our difference, 30. Now, this is your recursive formula. However, it is still incomplete because you have to give something along with the formula to input for the previous term. So we can say that f of 1 is 30. And so this is your full answer for a recursive formula. Okay? All right, so I've got some practice for you. I want you to go ahead and pause the video to complete this work. Unpause it when you are done. All right, welcome back. We are going to write the first four terms of each sequence. Assume the domain of the function is a set of consecutive integers starting with 1. That just means we want you to find terms 1, 2, 3, and 4. Okay? So we already have a formula here for us. So this is going to be pretty easy for us. Let's just create a chart here of n and f of n. We want terms 1, 2, 3, and 4. Okay, so all we have to do is plug in this 1 right here where the n is and see what our answer is. Okay. So I'm going to do the work off to the side over here. F of 1 is 1 minus 1 squared. Okay, well 1 minus 1 is 0. 0 squared is 0. Okay, so f of 1 is 0. Let's look at f of 2. F of 2 is 2 minus 1 squared. 2 minus 1 is 1. 1 squared is 1. So f of 2 is 1. Okay. F of 3, our next term, f of 3 is 3 minus 1 squared. F of 3, let's think about this. 3 minus 1 is 2. 2 squared is 4. Oops, didn't mean to write that, 4. All right, and our last term here, f of 4 is 4 minus 1 squared. f of 4. 4 minus 1 is 3. Squared is 9. Let's look at this. 0 to 1. The difference between 0 and 1 is 1. The difference between 1 and 4 is 3. And the difference between 4 and 9 is 5. Is this an arithmetic sequence? It is not, but it didn't ask us that. So it just asked us what the first 4 terms in each sequence was. It didn't specify it. So our answer is going to be 0, 1, 4, and 9. And you'd write your answer in set notation. You'd write it as a set of numbers there. Let me erase this so we have room to work. All right, here we have the second one. We need to, it's helpful to go ahead and write the chart. 1, 2, 3, 4. Okay, so again, we're going to plug in all of these n's into where the variable is right there. So I want to start with f of 1 is -2 times 1 plus 7. F of 1 is -2 times 1 is -2 plus 7. F of 1 is 5. You can always, at this step, just plug it into your calculator. If you have your calculator, you're more likely to get a correct answer as you plug it in exactly as you wrote it, -2 parentheses 1 parentheses close parentheses plus 7. If you write it in exactly like that and press enter, you should get the exact same answer. Calculators are very persnickety with how things are entered, so you do have to enter it correctly. Or you can do it manually and then verify it with the calculator is good too. It's always good to have backup, especially when you're doing a test. It's always good to make sure you know that you've gotten the correct answer every time. All right, and f of 3 is the one we're working on next. Is -2 times 3 plus 7. F of 3 is -6 plus 7. F of 3 is 1. I ran out of room. All right, now our last one, f of 4 is -2 times 4 plus 7. Plug that into our calculator. F of 4 is going to be -1. Okay. Now, if you notice, this next one is a recursive formula. I'm going to switch colors for this because we're given more than just in these cases, the explicit formula, but here we're given a term and the formula. And if you notice, it says for n is greater than or equal to 2. So that's saying, hey, we already gave you f of 1, so you don't need to solve for that. Just solve for 2, 3, and 4. All right, so this is just kind of unnecessary information, and but don't let it confuse you, okay? So we're just going to kind of ignore those for a little bit. All right, so let's go ahead. Oops, up here, we did not write our answer. Our answer was 5, 3, 1, and -1. My curly brackets are just scribbles. I'm sorry. That's how I do it. All right, so n and f of n. We already know what 1 is, don't we? In this case, it says f of 1 is 5. So f of 1 is 5. All right, so now let's plug in 2. F of 2 is the previous term. Remember, right here, this means previous term. Our previous term was 5 plus 2 is 7. F of 3 is the previous term Okay, f of 3, previous term is 7, plus 2 is 9. Well, I can already see the pattern. Previous term plus 2, 9 is 11. So our answer is 5, 7, 9, and 11. Okay, I'll erase this so I know what I'm, get a little bit more room here. All right, so for this one, I'm going to do n and f of n. 1, 2, 3, and 4. I already know what f of 2 is. F of 2. I wonder if I wrote that correctly. F of 2 is 3. I think it's supposed to say f of 1 is 3. F of 1 is 3. I did not write that correctly. So I'm sorry that you worked on that problem, and that is not what the book gave you. F of 1 is 3. Okay, so we're going to go with the way that the book is so that you can check your answer in the module that you're working on and make sure we line up with that. So F of 1 is 3. So in this case, we have 2 times the previous term minus 1. So f of 2 is 2 times the previous term is 3 minus 1. So that's 6 minus 1 is 5, right? So f of 3 is 2 times 5 minus 1. That's 10 minus 1 is 9, okay? F of 4 is 2 times the previous term is 9 minus 1. 2 times 9 is 18 minus 1 is 17. This one does not look like an arithmetic sequence to me, just by glancing at it, but it is a sequence. So 3, 5, 9, and 17. That is our final answer. I think this is our last problem here. Oh, no, not quite. Find the 10th term of the sequence, assuming the domain is the set of consecutive integers starting with 1. All right, they just want us to figure out what the 10th term is. All that means is we're going to plug 10 in wherever we see an n. Okay, so f of 10 is 5 times 10 is 50 plus 7. F of 10 is 57. That's number 1. All right, in this case, we're going to plug 10 in wherever we see an n. Okay, so in this case, we have 10 minus 1 is 9. So 10 times 9. So f of 10 is 90. All right, write the explicit rule for each of the sequences below. First thing we need to do is write down what our explicit rule formula is. Okay, f of n is f of 1 plus the difference times n minus 1. If you're making your note card, this is definitely something you should write down on your note card, the explicit rule. All right, so in this case, we do need to figure out what D is before we can start filling out this formula. So the difference between 6 and 7 is going to be 1. 7 and 8 is 1. 8 and 9 is 1. So our D is going to equal 1. So f of, let's actually write it up here. F of n is our first term, 6, plus D, which we know is 1. So I actually don't need to write that. N, oops, minus 1. Now let's combine, because we had a 1 as the difference. I did not need to write it because in math, the coefficient of a 1 kind of just disappears, right? And if I were to multiply it out, it would still remain the same. And so all I need to do now is go ahead and combine like terms. N plus 5 is my explicit rule. All right, so let's look at this one. The difference between 3 and 6 is 3, 6 and 9, 3, 9 and 12, 3. So f of n is f of 1, which is 3, first term, plus the difference times n minus 1. Step 1, we have to distribute. F of n is 3 plus 3 times n is 3n. 3 times negative 1 minus 3. F of n is this and this cancel out, just 3n. And that's our final answer. 4, 5, 6, 7 is 3, 7, 8, 9, 10 is 3, 10 and 13 is 3. I'm actually going to switch colors here because I want to do my work on this side. F of n is the first term 4 plus the difference of 3 times n minus 1. F of n is 4 plus distribute. 3 times n is 3n. 3 times negative 1, negative 3. Now I need to combine like terms. I'm going to start right here with my term of the variable. There's nothing to combine it with. Then I want to combine the positive 4 and the negative 3. They are different signs, so I'm going to take the difference. The difference is 1. The larger term is positive, so this is plus 1. F of n is 3n plus 1. All right, we're on our last practice. Make sure, I have not been saying it the past few times, but you should be pausing this, doing the work on your own, and then unpausing to review. You should have all of these practice problems written out step by step in your notes. If you do not, go ahead, rewind the video right now and go write them all down in your notes right this instance. Unpause when you're ready to continue. It says write the recursive rule for each of the sequences below. So the first thing we need to remember is, what is the recursive rule? Well, the recursive rule is f of n is f of n minus 1, which means previous term, right? Plus d, plus the difference. So I need to know what the difference is before I can really continue. 8 to 9, difference is 1. 9 to 10, 1. 10 to 11, 1. D equals 1. Here, 2 to 4 is 2. 4 to 8, 4, 5, 6, 7, 8. That's 4. 8, 9, 10. This is not, there is no common difference. This is not an arithmetic sequence. We cannot write this rule using this formula. I have a feeling your stuff will want you to write it. So let me just look really quickly. I'm sorry. Thank you for your patience. Please use this time to continue making sure your notes are neat and orderly and able to easily be reviewed. You have everything written down how you want it to be written down. Yeah, they do want you to go ahead and write it even though it's not an arithmetic sequence. So let us go back and look at this real quick. I'm going to erase that. There we go. All right, so 8 to 16, I know is going to be 8. So it looks like this is increasing by what, 2 to 4 to 8 instead of the common difference just increasing by adding. We're going to have to multiply and add. So we'll look at that in just a minute. Let's start right here at the practice first. D equals 1. Okay, so we've got f of n is going to be the previous term, f of n minus 1 plus the difference of 1. And then we need to say f of 1. We need to give a term. Remember, recursive formula is not complete unless you give a term with it. So this would be your recursive formula. Now, let's look at this one. So if we were to look at this formula, remember a lot of the formulas we looked at previously, there's a multiplier in front of the previous term. So that's what we're going to have to do here in order to get this. So we're going to multiply the previous term and then add to it. So your multiplier can really be anything. What we've seen thus far has been some 2's. So let's start with that and see if it works. We're going to take this previous term right here of 2. 2 times 2 is going to give us 4 here, right? Plus 0 is 4. And then, so that would be, if it's f of 2, our previous term there being 2. So what if we have f of 3? 2 times, what would the previous term be? 2 times the previous term, f of 3 previous term is 4 plus 0, right? So f of 3 is going to equal 4 times 2 is 8. So it looks like our rule is f of n equals 2 times, 2 times f of n minus 1. So just twice the previous term. We're just multiplying the previous term by 2. We're multiplying by 2 each time instead of adding. So f of n equals 2 times f of n minus 1, or 2 times the previous term. And you can see how our difference increased in an orderly pattern for us to be able to determine that. Now, with a recursive formula, you also have to include a term in there. So f of 1 equals 2. And that is our recursive formula.